Topic 5, relationships in triangles. Equidistant. Equidistant literally means equal distance. And so if something is equidistant, it is the same distance. So this is a perpendicular bisector. And so each of the points on the perpendicular bisector are equidistant to both endpoints. So those points are the same distance to both endpoints. Well, that brings us to the next, which is perpendicular bisector. Perpendicular bisector is a line or segment that is literally perpendicular or intersects at a 90-degree angle, and it bisects, so it cuts the segment perfectly in half. So if we look at this, here's the example. It cuts the segment into two equal parts. So AD is the same as BD, and it's at a right angle. Angle bisector. Again, there's angles and bisecting. That word comes up again. Bisecting means cuts perfectly in half. So we're just cutting the angle perfectly in half. So if we look here at this large blue angle, this red line is the bisector, and it creates two congruent angles on both sides, or two congruent parts. Concurrent. Now this sounds a lot like congruent. Congruent means, or similar to the word equal. Concurrent is totally different. So be really careful in the spelling and the saying of that word, how it's said. Concurrent means that you have three or more lines coming together in one spot. So if I look at this picture, it says when three or more lines intersect. These three lines are concurrent because they all intersect at the same spot. So those are called concurrent lines, and that point actually has a name. The point where they all meet is called the point of concurrency. And this whole topic, topic 5, talks about very specific points of concurrency on triangles. So the point of concurrency is literally point P. Where do those lines all intersect? So we're going to talk about those. And on these flashcards, they're all color-coded by kind of topic. So hopefully that will help. Circumscribed. Circum means around. That prefix, circum, so it means around a triangle. So if you look at the picture, a triangle that has a circle around it where it intersects all three vertices, or the vertex, all three, this circle is called a circumscribed circle. It goes around the outside. The circumcenter is literally that center of the circle. So this is the circle that goes around this center. That circumcenter is the point of concurrency. And the lines that are making that point of concurrency are the perpendicular bisectors. So each of these three lines, notice they're not necessarily going through the vertices, the vertex. They are going through the sides, cuts each side in half perfectly at a 90-degree angle. So when all three perpendicular bisectors come together, they create a point of concurrency, which is called the circumcenter. And that's the center of a circle that goes around the circumscribed circle. So now switching colors to green, this is a different type. So these all have to do with inscribed. Inscribed circle is a circle that's inside the triangle, and each side of the triangle is intersected equidistant from the center. So if the center is here, this distance, or the radius, and this distance are all the same distance because they're the radius of the circle. So they are all equidistant from the sides of the triangle. And that center has a name. That point of intersection is the incenter. So this triangle that has the circle on the inside, that center point is called the incenter. And it is the point of concurrency where all three angles get bisected. So look at these angles. These are this 1 and 2, those are congruent. 5 and 6 are congruent, 3 and 4 are congruent because they're cut in half. So the angle bisectors come together and they create the incenter. Okay, now here's a card that I'm going to move this out of the way. This card kind of helps you because it gives you kind of like a silly or easy way to remember. So if you're trying to figure out, okay, incenter, angle bisectors, circumcenter, perpendicular bisectors, this is the way I teach my students is they all start with vowels. If it's an angle bisector, you're finding the incenter and it's inscribed. So those three things all start with vowels, where the consonants, perpendicular bisectors, create circumscribed circles, and there's the circumcenter. So that's kind of putting just a way to help you remember and keep them differentiated. If you take good notes, you should be fine though. But to be honest, these words and what you do to get those points and how to find the incenter, they're really easy to forget. So just be aware. Okay, new color, median. So the median of a triangle, or the median, is kind of similar where you have something bisected, but it's just the midpoint. It's not a perpendicular bisector, it's just bisected. So the midpoint, and it goes across to the vertex. So that is a median. It's the midpoint of one side of the triangle. There's the midpoint, or the point in the middle, and then it goes across to the opposite vertex. The centroid is the point of concurrency of all the medians. So if we look at this picture, see how each side is bisected, or the point on the inside is the midpoint, and then they go across to the vertex. So all the medians put together creates the centroid. That is the point of concurrency. Altitude. Altitude, a lot of teachers and students even might refer to the altitude as the height. It is pretty much the same thing. In triangles, though, we call it the altitude, and you want to make sure that you understand the altitude or height might not be in the triangle. It could be actually on the triangle, like on as one of the sides. It could be inside, or it could be on the outside. But it's from a vertex, so one of the corners or the angles from the vertex straight down at a 90-degree angle with the other side. But this point right here, if I went straight down, see how it's on the outside of the triangle? That's okay. You can just extend the side lengths. And it's really tiny to see, but it doesn't have to be on the triangle. It could be an extension of that same line or side length. So that's the altitude. When you put all the altitudes together in a triangle, it creates the orthocenter. And this orthocenter is taking the point of concurrency of all the altitudes. So if I look at just this line here, M to B, it is starting at the point or the vertex, going straight down at a 90-degree angle. But notice it's not necessarily bisecting the other side. So from the vertex C, straight down at a 90-degree angle. These are obviously A to P is not the same as B to P. Those are definitely not bisecting that other side. So keep that straight. And then here's another way to remember. So the words altitude and orthocenter, again, those are vowels. And then another way, the consonants are the median and the centroid. So another way to remember it, but take really good notes and you should be okay. And then one last slide. This is a way to remember all of them, put them all together. So ways to remember. It says, the saying, all of my children are bringing in peanut butter cookies, actually helps. So all of, altitude, orthocenter, my children, median, centroid, are bringing in angle bisectors. Angle, bisectors, incenter, peanut butter cookies, perpendicular, bisectors, circumcenter. Now, if you are allowed to use notes on a quiz or a test, then you don't need this. But if you're not allowed to use notes, then this is a very helpful way to remember all of this vocab. So all of my children are bringing in peanut butter cookies. And again, I have left some slides blank on the end of this slideshow to help you out if you need them, and I hope this helps.